Hello everyone and welcome to the second part of the ZPY tutorial series. My name's Hugo. I am one of the co-founders at Zumo Labs, which is a startup that generates synthetic training data for computer vision models. In the first part of the tutorial series, we made a simple scene using Blender and ZPY. In this tutorial, we are going to be going into how to add logging to that scene, how to jitter the materials and poses of the Suzanne object in that scene, and also going into more advanced configuration with jittering. And finally, a little extra, we're going to add a depth image, an additional modality for the images here. So if you haven't done the first part of the tutorial series, you can look at the link below and go there and see that. Optionally, you can just start from the script that we finished at the end of that first tutorial series and be caught up for this one. Okay, let's get started. Alright, so now we have opened up our Blender scene. This is, again, a very simple Blender scene. If we look at the outliner here, we just have the Suzanne, the light, and the camera. Just an object, a light, and a camera. So let's go ahead and up at the top here, we will navigate to the scripting tab. This is the script that we created in the last tutorial session, which basically just steps through the scene. It segments the monkey, the Suzanne, and then it goes ahead and it takes 10 steps. So it'll take 10 images, and then in each image, it basically creates the color image. It renders a color image, it renders a segmentation image, and then it adds an annotation. And then it goes ahead and outputs annotations in Zumo and Coco format. So the first thing that we're going to go into here now is, if you notice here that every time we render an image and we add an image, we have to tell it the width and the height of the image, right? And it's kind of annoying that we have to pass that in every time, and it'd actually be simpler if we could just configure that externally and then clean up our script. So the way that we recommend to do this in ZPY is using Jin. So Jin is a configuration package in Python. It's called jinconfig if you want to search the internet for it. So we're going to go ahead and import that at the top of our script here. And at the very bottom of our script here, this is the part that runs at the very beginning, we're going to go ahead and say zpy.blender.parseconfig config. So what this line is going to do is it's going to look for another script, which we call config. It's already existing here, but let's actually pretend that it didn't exist. So let's delete it. Unlink, okay. Let's make a new script here. We will call it config. And you could have called this config foo, and then in the run script, config foo. Right? Give it whatever name you want there. So let's go into this config. So this is a jinconfig file. It's kind of like Python, but not really like Python. But basically what you're telling it is the value of keyword argument properties. So as we said before, we're going to import ZPY, always import ZPY. And then the first one that we're going to get rid of is zpy.blender.step.numsteps equals 10. Okay, so now that we've said the value of this keyword argument should be 10, we can actually go into the run function here and delete this. So now we no longer need to pass the number of images into the step function. It'll actually go ahead and do 10. Similarly, we can basically, let's take out the width and height parameters in here. So let's go back into our config, and we're going to say zpy.saveOrimage.addImage.width equals 320. We'll do the same thing for the height here, equals 240. And now that means that we can go back to our run And these calls here, the saver.addImage, we no longer need the height and width. We're actually going to make these images a little bit smaller just so stuff goes quicker. I think before we had them at 640 by 480. So then let's also go ahead and do the same for ZPY render AOV. So we can go back to the config here and say the value of the height and width here should be 320 by 240. There's all kinds of special tricks you can do with Jin, such as setting macros and setting functions. But for now, we're just going to go ahead and get rid of those simple things, which should make our script a little cleaner and our life a little bit easier. Okay, so now we have added configuration. We're going to go ahead and show you guys how to jitter objects. So jittering basically means moving the objects, such as moving this monkey head or moving the camera itself, because basically the way that deep learning works, you want a lot of variety in the position and orientation of objects. So if we want to actually train a machine learning model with this data, we're going to have to create that variety ourselves in the synthetic data set. And in order to do that, we're going to have to basically jitter both the camera and the object so that the relative position of the camera and the object are different in every single image. So first thing we're going to do is we're going to save the current position of the object, right? So ZPY objects.save pose and bpy.data.objects camera, and we're going to call this cam pose. Not camp pose, but cam pose, as in the abbreviation for camera. And then we're going to actually copy paste that as well and do it for the Suzanne. So why are we saving the position of the Suzanne in the camera? Because every single step we're going to move this, right? And if we jitter this and it moves a little bit and then it moves a little bit, over time it'll start kind of drifting away from the position where it started. This is fine if you're just doing 10 images, but if you start generating 100 or 1,000 images, the drift is going to get too much. So basically, in between each step, we're going to actually restore the position to the this original position that we save at the beginning, cam pose and Suzanne pose. So we're actually going to copy paste these lines, and at the very beginning, right here, beginning of our loop, what we're actually going to do is we're going to restore the position. ZPY objects.restore pose. So this line of code right here will take this object, the camera object, and return it to the position that we saved up here as cam pose. So our objects at the beginning of every step get returned to their original position. Now let's actually do the jittering. So there's a function we can call for that, ZPY objects.jitter. And of course, we got to tell it what object we want to jitter. So let's jitter, for example, the Suzanne object. So we're going to want to jitter that object. And then translate range. So we want to give this function, the jitter function, takes basically a tuple of 3 for a translate range argument here. This indenting is gross. All right. So this will be the range of how much do you want it to translate in the x dimension. So let's say somewhere between -5 and 5. So every single step, it'll randomly move anywhere from -5 in x to 5 in x. So the x-axis is this red axis here. If we actually look at that, 5 and 5 is basically anywhere from here-ish to here-ish. So basically has a random chance of moving anywhere from here to here in the x dimension. And we call that the jitter, the x jitter. And we're going to go ahead and do that for the other dimensions as well. So x, y, and then z. And we not only want it to translate, so jitter in a kind of translational way, but we also want it to jitter in a rotational way. So let's say rotate range. And we want to kind of see all the different angles and orientations of this Suzanne, right? We don't want to always see this kind of top-down angle. So what we're going to do here is we're going to import math, and the rotation jittering is going to go from -pi to +pi in every single rotation axis. So every single step, it's going to randomly rotate along all three axes from -pi to pi, right? So this first one here, rotating in the x-axis, it's going to basically rotate pi, so like this, and -pi, so like that. So basically you will get random rotation around this axis, and also for the y-axis and the z-axis. So that's how we go ahead and jitter the object. And we can go ahead and do the same thing for the camera itself. But we actually don't really need to do that. Because, right, if the object moves, then the position of it relative to the camera is always going to be different. So the only issue that happens now is, let's say that the monkey ends up here, right? Now if we look at the camera, the monkey's no longer in view of the camera. So we somehow need to make sure that the monkey is always in view of the camera. So we did provide a function for that, and some of you that are used to game engines might know this function already. ZPY.camera.lookAt, and you're going to say, I want the bpy.data.objects camera, right? I want the camera object, and I want it to look at the bpy.data.objects Suzanne .location. So you're basically saying every single step, return the camera to its position, return the Suzanne to its position, jitter the Suzanne object, and then make the camera object look at the Suzanne object, right? So that is how we're going to get the object and the camera position to change over the course of time, and in that way get a bigger variety of angles and view angles for the monkey itself. All right, so the way this video is edited, I'm going through and documenting the code in between each of these steps. So code does look a little different, but don't worry about it. You can always find this script in the comments below if you feel like you're lost and you just want to have the version of the script. So we've gone ahead and added the configuration using jinconfig. We've also added object jittering, so position jittering for the object. So now the next thing that we're going to do is add a depth image, right? So depth images are a different type of image modality. So first thing we need to say is, what is the name of this image going to be? Luckily, the same way that there's a make iseg image name, we provide a make depth image name, and you just provide the path. So whenever you say render, you just say, I want to render a color image at this location, I want to render an instance segmentation image at this location, and I want to render a depth image at that location. So whenever you click that, whenever it renders each frame, it'll actually save a depth image at this location. And you also want your saver object. You want to put an entry in that saver object of, hey, I have a depth image at this location now. So you're going to say saver.addImage, and you're going to add the depth image. The style of this image is a depth image. The location of this image and the output path is that, and the frame is just the step. So frame is basically allows you to say all three of these images were taken at the same time, or are of the same thing, basically the same moment in time of this simulation. This is a very simple simulation, so it's not like time really matters here, but you think in more complicated simulations, you'll want to be able to do that. Okay, so now we have depth images, we have jittering of the camera and the Suzanne object, we have the config through Jin. The last part that we need before we go ahead and run this is logging. So logging in ZPY is done using the Python's logging module. So all of this is set up to make it easier for you, where all you have to do is basically make a logger object, create logger.zpy here. So this will get the logger object associated with the ZPY module. We recommend you use this one because we do all kinds of fancy shenaniganry where we take that and change it. The lines are already here, but basically logging, there's different levels to it. So you can have an info log will basically print out every time. A debug log will only print out if you change the levels to debug. So to change the levels of the logging, we provide a convenience function in ZPy, so you can just say, it'll actually be the first thing we do in this script, zpy.logging.set log levels debug. So this will actually go ahead and set the logging levels to debug. And that is it for this scene. That is everything that we wanted to add. So I'm going to go ahead and take the time to comment and make these nice, and then we're going to go ahead and run this. Okay, so we have cleaned up the script a little bit. Nothing new has been added, and again, you can always find the latest version of this script in the links below. And this scene is ready to go. So if you are on Windows like me, you can go into Window and hit this toggle system console. And what that will do is it'll basically show you the terminal like this. And this terminal is basically where all the logging printouts are going to be, and it's where all the information that you, during the runtime, will come out. So if we go back to our main Blender scene here, in order to run this script and to run this scene, all you have to do is open up this panel here, the N panel again. It doesn't even need to be in the script view. You can actually go over here to the layout view and run it from here. Inside the render, this is the folder where the images will get dumped. So you can go ahead and basically change that if you want to. Change it to some other location that is more convenient for you. I just have it in the local temp data. So let's go ahead and clean that. So whenever I hit this clean button, if I open that folder, if I open this folder, it is empty. Let me show you guys. So opening this folder right there, boom, empty folder. So now let's go back to the Blender. Okay, so script is ready to run. We've set the output path. We've cleaned that directory to make sure it's empty. We've hit this open to open up the folder and make sure that it's empty. Now let's go ahead and hit the run button. And when I hit the run button, I'm going to go ahead and flip to the terminal screen, the window screen that I showed you before. So we're going to go ahead and hit this run button. Then we're going to flip to this. And you can see our script is executing. So we try to make it look pretty, but if you can see here, for example, every single step, there's this nice step. It's telling you this is currently simulating step number 4 of 5, 4 of 10. You see here are the debug, here are the printouts or the log calls that we had in our function, that this is an info log, this is a debug log. You can see how this one's an info and this one is set to debug. Let me see if I can zoom in a little here for you guys. All right, there we go. So again, it's kind of telling you everything that's happening. So restoring the position of the camera to cam pose, restoring the position of Suzanne to the Suzanne pose, This is some extra crap, but basically it's outputting the RGB image, the depth image, and the instance image. Despite these errors, it actually is working. So Blender will print out a bunch of errors sometimes that don't necessarily matter. Just make sure to check the actual folder to see that your stuff printed out. So this actually tells you the rendering for this took about 0.12 seconds to complete. So not quite 60 frames per second, but there's plenty of ways to kind of increase the rendering speed. If you guys want to see a video about that, definitely put comments below and let us know. Then it added an annotation, right, for that particular image. It basically finds the color and then pulls out the segmentation from that. And it's going to keep doing that all the way until the end, right? So if we scroll all the way down here, eventually it gets to frame number 8 and then frame number 10. And then you'll see a bunch of printouts where what it's doing is it's taking the annotation file and converting it from that internal saver object into a Zumo JSON and then a Coco JSON. So if we actually go back to our Blender screen, the Blender screen looks the same, and actually during the runtime it actually appeared like it was frozen, so don't get scared if your Blender gets frozen like that. And if we actually hit the open button here, go ahead and click on that button, you will see the file browser. And this is the actual data set. So if we look at these images, we can see how the Suzanne object is basically rotating. It's randomly rotating, and the position of it relative to the camera is random. Because we used a debug log, there's intermediate debug scenes for every render step. So if you want to know what happened at step number 6 right before it took the image, you can actually go ahead and open this Blender scene. This funny looking image here is a depth image, right? So depth images are basically black and white images. It's a single channel, and the whiter the pixel is, the closer it is to the camera, and the darker the pixel is, the further away it is from the camera, right? These are the segmentation images, right? So that blue color that we want the monkey to be segmented, and this is the actual color image, even though in this case it's just a bunch of gray images. So if we go into our secret little Zumo meta folder, this is the annotated images. So you can see here, this is our gray image with a bounding box for the monkey, as well as a segmentation polygon mask around the monkey itself. That is it, everyone. Thank you for watching the part 2 of this tutorial series. Stay tuned for additional parts of this tutorial series where we're going to go into how to use this Suzanne dataset to train a machine learning model and how to create a data pipeline with that. You can find out more information about Zumo Labs at zumolabs.ai, and you can always email us, the founder group, at founders@zumolabs.ai. Thank you, and see you later.